For this next hour and a half, we are going to be diving into one of the central opportunities and challenges of our time, artificial intelligence. Specifically, our presenters will show us some of the emerging uses of AI and social science research for public policy that could be rapidly generating new policy proposals or testing policy proposals using synthetic audiences. Opportunities such as these both broaden the scope of what behavioral research projects are possible, but they also bring new challenges to policymakers. Our three presenters are Professor John List, and Professor Iyad Rahwan, and Professor Sanjog Misra. But before we hear from our three presenters, we are honored to have Dr. Najwa, Aaraj, CEO of the Technology Innovation Institute, deliver a keynote address. TII, which is the applied research pillar of the Advanced Technology Research Council, is responsible for driving research and development for transformative technology outcomes here in Abu Dhabi. Dr. Najwa, please welcome.
Good afternoon, Your Excellencies, distinguished guests, and friends of innovation. It is my true honor to be here at BX 2025, and even more meaningful as it marks the first time this global gathering is being held here in Abu Dhabi in the UAE. We are here under the patronage of His Highness Sheikh Diab bin Mohammed bin Zayed Al Nahyan, a clear reflection of the UAE's belief that behavioral science belongs at the heart of governance and at the heart of innovation. It is ultimately about decisions and better outcomes for the people we serve. As I look around this room, leaders in policy, behavioral science, philanthropy, I'm reminded of the urgency and opportunity that define this moment. I'm a mathematician and computer science by profession, and nothing gives me more satisfaction to see algorithms, code, and artificial intelligence unlocking new possibilities and reshaping our real world, not only the digital world. And behavioral science will indeed become an essential tool for understanding, guiding, and amplifying its positive impact on our societies and our lives. So here's the question. How do we build public policy that is not only smarter, but more inclusive, responsive, and human-centered in the age of AI? Let me tell you what we're doing at TII and our conviction there. AI should not strive to only automate. It must be engaging. It must engage us as humans. It must amplify and augment our understanding of human behavior. It should deepen decision-making, not only by replacing judgment, not only by adding reasoning to models, but by enriching it. AI must empower policymakers, regulatory sandboxes, and others with tools that are intelligent, but also empathetic, culturally grounded, ethically aware, and more importantly, localized with the right data. Today, if you look around what's happening with all the models that have been issued since 2022, it's not only a game of models anymore, it's about specializing them for specific areas and having them engage where it matters and on the data it matters. And this is where Falcon, our open source large language model series that we have issued in TII since 2023, becomes more than technology, it becomes a beacon. Unlike models shaped by predominantly Western data and Western institutes, Falcon was built in the UAE for the UAE. It reflects our voices, our languages, and the diversity of our country. That's not just a technical detail, it is indeed a strategic edge. At BX 2025, today we're unveiling two uses of Falcon, which point to transformative potential in partnership with the Behavioral Science Group. First, a synthetic participant data set reflecting the UAE population. This marks an early exploration of how the public might respond to policy proposals leveraging previously collected behavioral data. It allows us to hear in advance the public's voice before a single focus group is run, or a law is drafted, or a regulatory policy is being put in place. Second, what we are showcasing is an interactive calibration tool offering behavioral coaching to policymakers and enabling them to make better decisions grounded in their knowledge based on available data as well. These don't promise certainty, of course, but offer greater clarity, and clarity can change everything. This is not future ideas that I'm talking about. These are two ideas that have been implemented with the behavioral science group. They're being tested today, and they're already influencing policy and policymakers. Think about that. A model trained to simulate human response, shaping behavior, and helping us make better policy than ever seasoned professionals, and it was built right here in Abu Dhabi in the UAE. Why does it matter? Because policy making is only getting harder. Trust in institutions is eroding. Challenges like misinformation, bias, climate change, public health demand faster, smarter, more adaptive, and inclusive responses. Traditional trial and error isn't fast enough in every context, and it doesn't work anymore. And in this case, synthetic participants give us speed. They give us foresight, and they help us focus on what's most likely to work before we commit real-world time and real-world resources. They're not a replacement for public engagement, of course, but they are a powerful accelerator and a bridge between intent, action, and ultimately impact. And this is not just a story of AI. What makes these breakthroughs possible is a multidisciplinary ecosystem, one that brings together technology, behavioral science, public policy, and data ethics. And I'm very happy to see this topic of AI being brought at the center of behavioral science today. It is the collaboration between government, regulators, research institutes like the Technology Innovation Institute, platforms like AI71, which enable secure, scalable access to models like Falcon and the platforms that are being built on top of Falcon. It is primarily the UAE's vision, where innovation is not locked in silos, but made interoperable across public and the private sectors. And it is your presence here that reflects a growing movement, a commitment to policy that listens, adapts, and learns, and is empowered by artificial intelligence. Let me close with this. At the intersection of artificial intelligence and behavioral science, we are still writing the opening. We only made a few steps towards something that is much bigger. A story not just about smarter systems and smarter decision-making, but also about fairer, more compassionate governance. A story about tools that don't just crunch data, but understand nuance and localize the context within the specific science. A story about tools that don't just predict, but help shape a future we build together. At the Technology Innovation Institute, we are proud to be part of that future, proud to build from the UAE, for the UAE, and for the world, and proud to ensure that public policy always stays rooted in something timeless, and this is nothing but the human experience. I thank you once more, and enjoy the next session.
Thank you, Dr. Najwa, for your words and for your pioneering leadership in this area. And now, our first presenter. Our first presenter is Professor John List, who is the Kenneth Griffin Distinguished Service Professor in Economics at the University of Chicago. His research focuses on questions in microeconomics, with a particular emphasis on using field experiments to address both positive and normative issues. Please join me in welcoming Professor John.
Wow. Thank you so much. Thanks, everyone, for coming. I want to also thank the organizers. I have never been here before, and this is just a fantastic venue. And the conference has been great so far, so thanks so much for including me. Okay, so my time is running quickly. I only have 20 minutes. I'm going to be very narrow in my comments to start. I'm going to focus on experimentation and how we can inject AI into experimentation. Okay, so my title will be Gen AI and Policy Experimentation. Now, where I'm going to start is I'm going to start by outlining what I see as the goals of policy experimentation. And then from there, I'm going to introduce AI through a few of my papers that I've written recently. One was just published in Nature Human Behavior, and the other one will be sort of a guide to how we can think about injecting AI into experimental research. Okay? So let's start with the twin policy experimental goals. So goal number one is really internal validity. Experimentalists are celebrated because we establish a causal relationship between two variables. In our parlance, it's called internal validity. It's understanding the effects of causes and the causes of effects. Okay, so I'm going to call this EP1. EP2, I'm going to think about going from that internally valid estimate to something that is spatially removed, temporally removed, or scale removed. Now here, importantly, EP2 captures what we call external validity and scaling. Now I'm going to take a time out here and talk a bit about scaling because I think this is the most important part of our science that is underrepresented in our research in an area where we can really make big impact. Okay, the reason why is because when I first started thinking about scaling, it's an incredibly vague topic. In fact, it's disturbingly vague because it mixes and meshes a bunch of things together. Now, I want to give two very simple definitions. One is external validity. That's a question of whether our treatment effects generalize. Okay, so simply, I have a treatment effect in one city. Does it generalize to another city? That's external validity. Scaling is what we are mostly interested in as policymakers. Scaling is, does the benefit cost profile generalize across scale, space, or time? In the end, that's what we're really interested in. Of course, scaling involves external validity. That's part of it. But scaling is actually a much more interesting topic than straight out external validity. Now, I realized this some years ago. I started a research agenda on scaling to think about what is the science of using our science, or what is the science of scaling. So I wrote a bunch of papers, and all of these papers are very accessible. They're simple economic models about why the scaling effect could happen. And then there's a bunch of empirical work testing what is the case for ideas when they do scale, what happens when ideas don't scale, and why don't they scale? Okay, so let me take a pause here. All of you are at this conference, so you want to change the world for sure. You would all, if I said everyone raise your hand who wants to change the world, you'd all raise your hand. Let me ask this question. How many of you have ever read any of my academic papers on scaling? If you raise your hand, I'm going to call you, and you're going to have to answer a hard question about it. Okay, that's the problem. Nobody raised their hand. As an academic, we feel like when we write a paper, two people read it, the editor and one of the three referees. And then we argue we're changing the world. That's not changing the world. The reason why is because it is difficult to read academic papers. In fact, it's really difficult just to read abstracts from a paper that's in a different field. In our world, we speak economese. We have a bunch of math. We have a bunch of jargon. It's very, very hard to understand and let's say, implement if you're a policymaker. So the reason why I wrote that book is because I was tired of all of my scaling work not being implemented or not being understood. So I wrote that book so my dad, the truck driver, could understand exactly what are the economics behind scaling. Okay, so today's lecture, I want to pick up from that book, and I want to think about where can we inject AI to help put the book's learnings into perspective and to also put them in motion. Okay, so the first question you might want to ask is, where can AI fit in that voltage effect book? In short, everywhere. Okay, now I want you to think about EP1 and EP2, and I want you to think about the science of using science, or the science of scaling. So when you think about it, there are many different steps to running an experiment. You might start in the world of experimental design. And then, of course, you collect data, or you generate data, and then you analyze the data, and then you interpret the data. Now, my thesis today is that Gen AI can play a very important role in every one of those steps in which we're trying to accomplish EP1 and EP2. Now, first of all, a bit of a warning. It is also clear that when we have such a powerful tool, we also have to think about moral hazard. Moral hazard simply means it's really easy and costless now to do things, and to do thoughtless things, to do, let's say, non-ethical research, or run down the wrong path. So that's exactly why we wrote the paper, the 12 simple basic lessons of using AI in experimentation, is because we wanted to draw out various lessons over the design phase, the data generation phase, the data analysis phase. And essentially, all of those there are the 12 lessons, and I'm going to unwrap a few of those now. Okay, and I'm going to start with a design example. The design example is going to start as experimentalist. In the academy, we have something called pre-registration. We have something called PAPs, pre-analysis plans. These are meant to tie our hands, so to speak, so we don't generate new data after we find a result we don't like. Or we continue to analyze the data the way that we promise you. We were going to analyze the data from the very beginning. That goes all the way from heterogeneity or moderators all the way to mediators. Okay? Now, I think Gen AI has a very important role here. It can democratize that research. It can be very costly to put together a pre-registration plan that's right, or a PAPS plan. Every day that goes by, Gen AI is helping people to create a path that is costless. And I'm very optimistic about this way to democratize our own empirical research so it's not a haves and have-nots situation. It's also the case that it helps us to go beyond the traditional ways we think about experimental research to have Gen AI explore different mediation paths. And what that means is different mechanisms. Why does the idea work? That's a mechanism. As a policymaker, you should always ask why. Because the minute you understand the why behind something, it allows you to generalize and be more confident in your scaling. But then you also have moderators. Every session I've sat in, people have talked about heterogeneity. They've talked about how effects are different for one group than another. Gen AI can help in that world too. Now, it's often the case that we miss as research. Look, I've been doing this for now 30 years, and we miss important moderators or mediators that might be at work. Having a helper. Now, I'm not saying somebody to substitute for us, but somebody to complement our original design can be quite helpful. Let's now go from design to implementation. And here what I want to focus on is what I call option C thinking. So if you've picked up the voltage effect, what you've learned is that nearly every time we try to scale, there is a voltage effect. What I mean by that is the original promise that the researcher gives you is usually never held true when you scale something. The voltage effect is that the benefit cost profile depreciates or deteriorates as we scale. And it happens both within a market and across markets. Okay? I call that the first law of scaling, that every time the voltage effect will cause a benefit cost profile change. Okay, so that's the way we think about research usually. Now, the way I want you to think about it today is that how can we be sure that when we scale an idea or a policy, how can we be more confident that there will not be a voltage effect or that I am minimizing the voltage effect? Option C thinking is essentially flipping the traditional research agenda. Usually what we do is we do an A/B efficacy test. So we have an idea, we want our idea to have the best shot of working. So we do an A/B test. It's called the gold standard, right? That's an experiment. Put half the people in control, half the people in treatment. But we tend not to remind people that we've just done an efficacy test. Because the way our world is set up is we are incentivized to find large treatment effects. Find large treatment effects, find a mechanism or a mediation path, write it up, publish it in a top journal, and then move on to your next efficacy test. At least in medicine, they call it an efficacy test. And then they have to do phase 1, phase 2, phase 3. We do not have that in the social sciences. So I don't want to take away efficacy tests. What I want to do is I want to simply augment them with option C thinking. Okay, so here's how I think about option C thinking. I want you, instead of starting with an efficacy test, start by saying, what constraints, what warts will this problem face, or this idea or policy face, if we scale it? Now, from the beginning, I want to explore, will the idea still work with those warts in place? So I want you to do your A/B test. That's great. That's good science. But alongside the A/B test, I want you to use option C thinking. Make maybe a C or a D or an E branch. Now, the analogy is meant to get researchers to stop focusing on creating large treatment effects for efficacy tests and for academic papers. The change is meant to truly speak to policymakers, to truly tell them, look, I've kicked the tires a bit, and this idea will work at scale, even accounting for these two warts. Now, you might be thinking, well, where are these option C ideas going to come from? Now, I first want you to say, well, what new constraints will it face? There's a Petri dish study. If we scale it up, will there be input or output constraints? For example, what key factors might impact scaling? I want you to think about, is the mediation path that I found in the Petri dish, is that even available at scale? Are the moderators similar at scale? What the moderators essentially mean are the representation of the population of people. Remember, what we're really talking about here is populations of people and populations of situations. And then when we have those in hand, we can scale with more confidence. I think this is the area where Gen AI can really help. And this is where I want to focus and show you an example that I just did a few weeks ago. Okay, on the side is an early childhood program that I put together back in 2010. And it's called the CHECK program, Chicago Heights Early Childhood Center. And there, instead of choosing the 30 best teachers we could find, we knew if the idea was ever scaled that we would not be able to only have 30 great teachers. We knew we would have to hire 30,000 teachers. So let's check and make sure that our idea will work. Our curriculum will work with the types of teachers we're going to have to hire at scale. Okay? So here's what I did with ChatGPT. Now this is very simple. Anyone can do it. I'm first of all going to train ChatGPT based on my option C paper, which was published last year in Nature. Okay, so I'm simply going to take that paper and I'm going to train ChatGPT. I'm then going to say, look, the aim of my project is as follows, and I'm going to have 6 prompts: the research question, a description of the research, etc. Okay, so I'm going to give that as a prompt. Now I'm going to actually punch in the real data after it trains on my paper. It will ask questions like, what is the impact of preschool on future achievement? That's what the research was trying to answer. Number 2, this is an early childhood program in the south side of Chicago. Okay? And then et cetera, et cetera. Sample of children from low-income families. Children are randomly assigned in an A/B test. Now remember what I'm after here. I'm giving it the option C thinking paper from Nature, and I'm saying, here's what I'm trying to do, and I'm asking it for 3 option C ideas. Quick poll. How many of you think it will kill it? Raise your hand. How many of you think it will be terrible? Raise your hand. Okay, let's check. Here's idea number 1. What it fed back to me was my own paper. Okay, so that's not so good, but maybe it's okay. So the first thing it said is, why not try teachers who aren't incredibly gifted teachers? So that's exactly what it fed back to me. And then it said, this is a test because it still boosts achievement when the teaching staff and resources reflect ordinary public schools. Okay, so it's 0 for 1. It just simply took what was in my Nature paper. Okay, let's look at idea number 2. Idea number 2, it says maybe you should look at the classroom size. That's not too bad. That's not too bad. And the thinking idea is instead of capping classes at 15, which was my original study, maybe have a larger class size, like 20 or 25, and then see if it still works under multiple classrooms in that way. And then it gives me the rationale. It says when you scale it, you might not have the resources to only have classroom size of 15. I'm going to give it credit for that. That's pretty good. And then option C, thinking idea number 3, maybe you should vary a moderator and do causal moderation called parental engagement. I like that too. I like that too. Now, again, the rationale is that maybe in the original setup, you might have parents who sign up who are just really interested in early childhood education or really invested in their children. Would your idea work with parents who aren't very invested, or at least are constrained in some way that they cannot do what the original parents did? I'm going to say check here. This is another good idea. 2 out of 3 isn't bad. That gives me a lot of hope, because before I thought it's human imagination that will cause option C to die on the vine. Now, a simple prompt, and this took 10 minutes to give ideas. I could have asked for 5 more ideas. I didn't, but who knows what it would have brought up. Okay, I only have 20 seconds left, so I'm going to jump to data analysis. This is also an area where this particular tool can be super enlightening because it allows us to standardize. It allows us to standardize using tools of AI so that it will be a lot easier for people to replicate. Now, you can also think about, are there ways to use AI to enhance experimental power? There is. In fact, a simple reassortment of how you analyze your X's in your regressions from a simple experiment, we can pick up 4 to 8% more power in an experiment just by using ML techniques. A lot of times people say to have more power, you need more of a sample. It's not true. That particular paper shows how you can pick up a lot of power just by thinking about using ML and using ML in your regression approach. Now, one bit of caution here, it would be very dangerous to say that we want a science of homogeneity. The one wart I see is that if we rely on these as a substitute for our own critical thinking skills, our own way in which we think through problems and come up with solutions, we might end up with the great innovativeness and heterogeneity in scientists being whittled down to something that looks very homogeneous. That should be something we talk about in the discussion section. Now, I'm going to end here with my last slide. The takeaways here are that there are many different areas where AI can help our experimentation, and I'm extremely bullish because of selective data generation. We get to decide where to generate the data from. Also, if you go all the way down to number 3 here, option C thinking, which was my example. Now, I'm going to end with a thought. Economists used to visit the pin factory to see how the pin factory is operating, and then to write down economic theories about the pin factory. That's what Adam Smith did, of course, when he talked about comparative advantage and specialization. In today's world, as policymakers and academics, we can not only visit the pin factory, but we need to tinker. We need to tinker and see what works and why, and figure out EP1, but also, will that idea scale? Thank you so much for your attention. I'll be back soon.
Thank you, Professor John, for presenting this fascinating research. I can already see the many ways in which it's relevant to all of us sitting in this room today, regardless of which sector we work in. Our second presenter is Professor Iyad Rahwan. Professor Iyad is the director of the Max Planck Institute for Human Development in Berlin, where he founded and directs the Center for Humans and Machines. Rahwan's work lies at the intersection of computer science and human behavior, with a focus on the impact of artificial intelligence and digital media on the way we think, learn, work, play, cooperate, and govern. I would now like to invite Professor Iyad Rahwan to deliver his presentation on how AI can increase dishonest behavior in humans. Please welcome.
Thank you so much. I'm delighted to be here. Thank you so much for the invitation, and especially to the BSG group for hosting this event. So today I'll talk to you about research that we do in my lab. So my lab has a team of about 50% computer scientists, AI scientists, and 50% behavioral scientists, so behavioral economists and psychologists and cognitive scientists. This is a picture from our last retreat. And we do experiments where we make use of both pieces of like knowledge from both fields, and to really get these people to talk to one another, right? So the topic I will cover today is a collaboration actually with some of my former and current lab members. Niels Kobis, who's a former lab member, Zoe Rahwan, who's my wife, is sitting there as well, and she did most of the work, and Jean-François Bonnefond, collaborator at the Toulouse School of Economics, and some of our students. And the question really is about making AI safe. We often think about AI safety in the context of controlling what the machine can do, right? So you can contain the machine, you program the machine carefully so that it's ethical, it follows guidelines, it follows laws, and so on and so forth. But I think what's missing from this discussion often is what I call behavioral AI safety. So the idea that AI as a tool might alter human moral behavior. So it might give us new temptations, new capabilities that change the way we act in the world. And I think this is a big opportunity for people from behavioral science and behavioral policy to think about the human factor in AI safety and AI ethics and alignment. So a few years ago, we wrote a paper in which we wanted to speculate about this. How can machines corrupt human behavior, right? So we wrote a paper called Bad Machines Corrupt Good Morals. It's a play on bad company corrupts good morals. And we identified a few mechanisms that can potentially do this. One is AI is a role model, right? So if you go on social media, for example, you might observe people, let's say bots, spreading misinformation, and you might be more likely to spread misinformation yourself. Or you see people using foul language or bullying against one another. That might normalize bullying among humans, right? So that's one possibility. AI can also be a partner in crime of some sort. AI can be an advisor, so it can give you advice that might lead you to break the law or perhaps break ethical norms. And finally, AI as a delegate. So we might be able to delegate tasks to machines that we wouldn't do to behave in unethical ways, in ways that we wouldn't do ourselves, right? So this is what we'll focus on today. And I'll describe this experimental work that we've done in this area. So the motivation is, so focusing on delegation now, the motivation is that delegation to machines is growing, right? So on one hand, we delegate more tasks to algorithms. We let algorithms, for example, set prices. So for example, on Airbnb, you can delegate to the machines to do the pricing for you, okay? You don't have to set the prices yourself. There's also more evidence of, for example, people delegating to algorithms to set prices and trade on their behalf in the stock market, right? And there's evidence actually that these algorithms might start colluding with one another and basically following anti-competitive behaviors on behalf of people, right? So why does it matter? And why does it matter now? The reason it matters now is because there is now a larger scope for delegation. Now we have AIs in our pockets. There's a rise in agentic AI, so AIs that can do things on our behalf, perform tasks. So there's a larger scope in which any normal person can now delegate to machines. The delegation can be quicker compared to delegation to humans. It can also be more accessible. Now everybody can have a secretary or an assistant, whereas before AI, not everybody has assistants. And also it's less morally costly, potentially, to delegate to a machine. So this is the main research question for us, is can delegation to AI increase unethical behavior? So we wanted to study this experimentally in the lab in a control setting, but we also wanted to be able to identify this phenomenon, really test the phenomenon using a validated task. So what we've done is we took the die rolling game, which is a well-studied game in behavioral economics. So the idea is that you roll dice, and only the participant observes the outcome of the die roll. So you might get a 1 or a 2 or a 6. And the more you get, the higher the number, the more money you can make, okay, as a participant. And because the experimenter nobody observes the outcome of the die roll, you have incentive to over-report, right? So as experimenters, we can see the distribution. We can see if too many people are reporting 6s, or if the average of the distribution is shifted, then we know that people are cheating more under some conditions than others. So, and this paradigm really goes back a long time in behavioral economics and has also been shown to predict real-world unethical behavior. So, here's what we do. We have a principal. So this is our participant who's performing this task. In the control condition, they perform the task on their own. They can also delegate the task to a human by giving instructions, or they can delegate it to a machine. And the question here is, will the person delegate more unethical behavior? So we'll ask the machine to cheat more on their behalf than they would do themselves, and maybe even potentially more than they would ask a human to do so. But the flip side of the question, or the second part of the question, is will the machines comply more than humans with such demands? Okay? But we can't, so how do you ask the machine to perform this task for you. So there are many paradigms for programming machines. Prompt engineering, asking ChatGPT using natural language is a very modern approach. It's a very new phenomenon, but typically we have rule-based approaches. So you can give rules to the machines about how to behave. You can give it data to say, use this data to learn how to behave. Or we can give it the goal, our objective, high-level objective. And finally, we can give it a prompt, or have a conversation with the machine. And we wanted to mimic those things for the die rolling task. So the first thing is, this is a simple case of a die rolling using rule-based approach. So basically, for every outcome of the die roll, you ask the machine to, you specify what the machine should report. Okay, and if you want to cheat, you could say, if you want to cheat maximally, you just say to the algorithm, always report a 6 regardless of what you observe. Or maybe if the number is too low, you can increase it a little bit and so on. In the supervised learning condition, we basically allowed people to choose from one of 3 data sets. So they can specify which data set they want to choose to train their algorithm. Right? So in the first data set, obviously seems to be reporting accurately. Second data set is a bit of over-reporting. And in the third data set, the person who generated this data set is always reporting a 6 regardless. And finally, or not finally, thirdly, we have the idea of just giving the machine a goal. So maximize profit versus maximize accuracy, right? And all you need to do is you choose the dial. You set the dial for the machine. And of course, you can ask the machine now with ChatGPT, for example, to report for you, and you describe in words how you want the machine to behave in this task. Okay, so you can say, for example, this message asks the machine to perform ethically, but if you're undecided, I don't know why the machine would be undecided, but if it's undecided, that it should take your interests into account. So this is a subtle way of asking the machine to cheat a little bit, right? So let me show you the results now that we got. So first, this is consistent with what we know about the die rolling game. Is surprisingly, most people don't cheat on this task, even though they can get away with it, okay? So only about 5% of people cheat, fully or partially. So here the dark red means fully cheating, so somebody who always reports a 6, and then the light red denotes somebody who's cheating partially, so some of the time. So now let's see what happens when you can program the machine to do it for you, rather than do it yourself. Surprisingly, for us, this percentage increases substantially, okay? So now just being able to delegate this task by programming a machine to do it, now about 25% of people cheat, right? I think that's a significant number, and this is across 2 separate studies. If you just you have to pick the data set to train the machine to do this task for you, the number jumps again substantially. Now almost half of the people cheat partially or fully. And if all you need to do is set the dial, the number goes almost to 90%, 85 to 90%. So, this is a behavioral exchange. You know that these are massive effects, right? So you change only the interface for a very simple algorithm, which is reporting a die roll. By changing the interface, you completely alter the propensity for violating moral norms in this case, right? So it really matters how we program the machine. Okay, so I did not cover the ChatGPT version of this. So what happens when people can tell the machine what to do using natural language? We had no prior at the time. But basically, first of all, let's look at requests, because ChatGPT is less predictable and we're interested in compliance, right? So whether machines comply with the request. So let's look at the request, first of all. So it seems that people do request, more cheating when they can ask a machine than when they do it themselves. So here it's about 25%. It's not more than when they ask humans. So when they write a prompt to another human being to perform this task, they would ask for just about the same amount of cheating. And this is robust to whether you were asking people themselves what they intended, or whether a language model interpreted what they intended, or whether a human rater interpreted their messages. Okay? So now what happens on the compliance side? So do the agents comply with the requests? So now I'm showing you here how much cheating happened by the agent, okay? Not by the principal who's requesting the cheating, but by the agent who's performing the task for you, the machine agent and the human agent. So it's the person you asked to perform the task. So when people asked for honest reporting, then both machine and human reported honestly. So they both complied with the honest requests. Sometimes they cheated anyway, okay? But this is a very small percentage. I don't know why they did this, but that's what they did, even though they were incentivized to accurately follow your intentions, okay? But then, when the principal wanted partial cheating, we can see that there's a beginning of a difference, right? So now the machines are a bit more compliant, sometimes overshooting actually. They're fully cheating for you on your behalf. And when the principal requests full cheating, then the machines are way more compliant than humans, okay? This is the second moral hazard, right? So the first moral hazard is people ask for more cheating. And the second one is the machines comply more than human agents. Substantially more, right? After all, this is the job of AI, is to follow our desires, right? It's the genie that will fulfill your wishes. So for me, that's an important observation, because it shows that to solve this issue, to minimize cheating through machines, we need to improve the machines, to push back when people ask them to do unethical things. And we also need to work on the humans to reduce their propensity to make such requests in the first place. Subsequently, we asked, well, can we prevent the machines? Is there something we can do to make the machines resistant to such requests? So first of all, we tested different models. So GPT-4, GPT 4.0, Claude 3.5, as well as an open source model called Llama. And we tried different guardrail strategies, where we prompt the machine not to comply with these kinds of requests. So without guardrails, you can see this is the top. With no guardrails, they're all fully, very highly compliant. And they are also resistant to a lot of guardrails, right? So you can give them system-level general guardrails to be ethical, to be, or even specific guardrails. And GPT sometimes is responsive to those guardrails, but not always. But a lot of other models are not. So the only thing that seems to work is this very, very specific prohibitive guardrails, where you ask them specifically to not misreport die roll outcomes in the experiment, right? So I think we need obviously more work to understand this phenomenon and how to build such guardrails, but we're starting. I think this is a good start to show that there's kind of heterogeneity in responses. Of course, die rolling game is just one type of game, and we did some follow-up work on tax evasion, and we used the tax evasion game, which again is kind of, I think is a very realistic scenario, because we already, by the way, this is ChatGPT idea of an accountant. So you have a human accountant or a tax accountant, and you also have systems like TurboTax that people use to report, to do their taxes for them. And obviously, systems like TurboTax are going to be much more interactive and perhaps use language to work with you to do your taxes, to minimize users' efforts. So we use the tax evasion game to do this. We basically have people do a task, they make some income, then they have to report their income, and we would tax some of that income as the experimenters. And of course, they can underreport their income and make more money as a result, because they would be taxed less. Again, this has been studied for a long time. There's over 40 years of research using this game, and it's also been shown to be externally valid, so in the sense that it predicts real-world kind of tax reporting behavior. And again, in this case, you could see that here when we're looking again at the behavior of the agents, so machine agents and human agents, when you ask them to be honest in tax reporting, in income reporting, or to ask them to partially cheat or fully cheat. excuse me. So you can see here that, again, once more, language models are more compliant with request to full cheating. Not all the way in this case, but again, highly compliant. And again, we have a similar picture of like highly heterogeneous responses across different, two guardrails across different language models. And again, you have to be very specific to be able to prohibit this kind of behavior by the AI. So to recap, what I've argued for is that we need to take behavioral AI safety seriously. We looked at the idea of like a principal and an agent. On the side of the principal, there's a risk of less ethical intentions being expressed when delegating to machines. And on the side of agents, there's a risk of greater compliance through machines. And we can mitigate these things through task-specific guardrails, and also that I should note that when given the choice, people did not always want to delegate to machines, so they were often happy to also do the task themselves, which might give us some hope in this kind of task. Thank you so much.
Thank you, Professor Rahwan, for showcasing such an interesting dimension to this topic. I would now like to introduce our final presenter, Professor Sanjog Misra, who is the Charles Kellstadt Professor of Marketing at the University of Chicago. His research focuses on the use of machine learning, deep learning, and structural econometric methods to study consumer and firm decisions. I would now like to invite him to present on the personalization of nudges using AI. Please welcome.
Okay, thanks for having me. So this talk is going to be about connecting to the previous two talks. It's going to be about the interaction of AI with behavioral science. But rather than talk about language models and GPT, we're going to try and build our own little generative model of nudges. So just to level set, what we want to do is generate a nudge that nudges or kind of gets a participant to engage in some action that we want them to engage in, right? And so this is one of my colleagues. He won one of those shiny medals that they hand out in somewhere in Northern Europe. This guy here. And so what I'm going to try and do is essentially take the idea of a nudge and try and do two things. One, I'm going to try and optimize it to say, can we find a nudge that does the job really well? And two, I'm going to try and personalize it, which is to say, I'm going to take the nudge and optimize it for a given individual, right? So rather than have like one generic nudge, we're going to try and kind of see if we can personalize it. Okay, and the context I'm going to do this is going to be with, in partnership with the state of California, SNAP program. So SNAP, locally it's known as the Food Stamps program. Essentially, if you're poor in the United States, and if you can prove you're poor, so you go through this arduous qualification process, and as long as you can show that you're poor and document the fact that you're poor, you get about $200 a month for food, and food alone. In spite of this program being around, there's a lot of people who either don't sign up for it or kind of are unaware of it and so on. But that's not the problem I want to deal with. The particular problem that I'm going to deal with is the following. Imagine that you are a citizen who has proven that you're poor, you have qualified for these benefits, and then 6 months later, you have to fill out a form. This is called the SAR-7. It's a recertification form. It's a 2-page form, and essentially it says, I'm still poor. That's what the form is. But if you don't fill out this form, you lose your benefits, and you have to start again, right? And so the whole qualification process starts again. It's expensive, obviously, for the citizen. It's also expensive for the government because they have to do the whole process again. So ideally, the government would like you to just fill out this form because it's required by federal law and get the citizen to kind of stay on the program. The fact is that over 60% do not fill out this form and lose their benefits. So our job is going to be to essentially remind the citizen that you need to fill out this form and get them to fill out the form. That make sense? Okay. So the idea of a nudge, like they had already done it, right? So the state of California was aware of Richard Taylor's work, and this is the nudge that they were sending out. And essentially, it says something like, hi, whoever, get CalFresh here. Get CalFresh is the local California name for the food stamps program. And in order to keep getting CalFresh, you have to fill out your semi-annual report, do this as soon as you can. So just a standard reminder nudge. The question that I kind of had, or you should have, is how do we know that the language of this nudge is optimal? Somebody came up with this language, but how do we know it's kind of the right language? So in order to do that, I'm going to start thinking a little bit more carefully about how we come up with interventions. How do we come up with choice architectures or nudges that we think are going to work? So let's go back to my little diagram here, and I'm going to embed this in a theory of communication. So the theory of communication basically says there's always going to be a sender, there's going to be a receiver. And we cannot telepathically communicate, so we have to encode our ideas in kind of some language so that we can design this message. We send the message across. The receiver then receives that message, decodes that message, and internalizes the idea that that message contains, right? And so, there's lots of places where things can go wrong. So, for example, I'm sure many of you have had this experience with your better or lesser half, where you say things like, that's not what I said, and he or she says, that's not what I heard, that's not what you meant. People have these experiences, or just me? Okay. There's also noise, right? Like there could be literal physical noise. I'm talking to you here, and imagine if a jackhammer was going on outside, you wouldn't be able to hear my message. It could be clutter in the sense that there's too many emails that pop up in your inbox. So there's lots of places where things could go wrong, right? But the key point is, like, how do I think about how nudges were generated? If you're smart, like I am, and when I'm talking to my better half, I try to figure out what she wants to hear and how she wants to hear it. So if I want to get my way, I have to design my message in such a way that I'm safe, right? And get her to kind of agree with me. And so the goal is to kind of design this nudge. The current state of the art is the following. There's a bunch of stuff that you could say. That's that white space there, up there. There's a set of relevant things that you could say. So the space of the choice architecture itself, that's the gray area. And then somehow we pick one of those. How? Yeah, we just know which one to pick. Now, you might say, no, I'm clever. I'm going to do an A/B test. So you'll pick two, and you'll kind of test to see which one's better. And if you're cleverer, then you might have 8 of them or 10 of them. But there's this finite number of dots you pick. You test them out. That's one way. But really, the trick that you're pulling is you're trying to anticipate what is it that will work, and then you design or you select that nudge by anticipating that. Okay? That's great. So that's the current technology that we operate in. Now, there's a slight problem with this. What we do know is that that nudge is actually going to go to more than one person. Why is that optimal? How is it that the same, like when you're talking to your spouse and you're talking to your coworker or you're talking to your boss, you don't use the same language. You don't use the same style or the same kind of way of saying things. Maybe what we want is to have many nudges, right? One tailored to each individual. But in order to implement that, we'd have to know what people prefer. How do they want to hear things? And if we could figure that out, then we could personalize nudges, and it would be more effective, right? At least theoretically, that's true. How are we going to do this? Well, if you're a person like me, you just build a machine. Okay, so that's what we're going to do. We're going to design a machine that's going to learn the preferences that people have over language, specifically the language of the nudge. And then we're going to build a generative model of nudges such that it generates a personalized nudge for every individual. There's some challenges in this process. Now, just to give you an idea, you can't use language models for this because language models are generative, they're not bijective. So you can go from, you can generate language, but you can't optimize it easily, and you can't personalize it because you can't optimize it. We're moving in that direction, but we're not quite there yet. So first, I'm going to define a language. And I'm going to steal ideas from Chomsky. So I'm going to define a language by using what are called context-free grammars. Doesn't matter what it is. It's stolen from linguistics, but it's also useful in computer science. So if you think of languages and computers, like a compiler, is a language, right? So Fortran is a language, and C++ is a language. So language has structure. It has a beginning, it has an end, it has symbols, it has grammar, it has rules. So if we can just define all those rules and grammars, we have our own language. So I'm going to define a language. It's going to be really simple and silly. And then I'm going to say, can we figure out what people's preferences are over the components of that language? So I'm going to learn people's preferences, and then I'm going to optimize it for every person. Okay? So just to give you an idea of how we can pull this off, take this particular nudge. This is what the state was sending out. And the first thing I'm going to do is I'm going to modularize this. So the starting point is to realize that there's an infinite number of ways I could say the same thing. I could change things in so many ways that that space is too big. So let's kind of manage it a little bit. So I featureize it. Here's one simple way of doing it. So I can start by saying, hey, look, there's a salutation. Why did we say hi? Why didn't we say hello? I don't know. Maybe we should try hello. So it turns out, get CalFresh here, we have to identify the source of the message. That's legally required, so leave that alone. What's the benefit to keep getting CalFresh? What's the task to fill out? What do I fill out? The object, which is the semi-annual report. When do I need to do it? And there's a call to action at the end. So those are components of my language. I can add a few more things to it, which I did. This is done with the team that was sending out the nudges. So you'll notice that I basically added components and then given it options. So hi versus hello, get CalFresh here is fixed. The consequence to keep getting, in order for you to keep, to avoid losing, in order for you not to lose, you'll notice that there's 2 of those are loss frames and 2 of those are like status quo frames. There's an urgency element next month or by a certain date. There's an endowment component, which is CalFresh versus your CalFresh benefits. There's all these. The grammar is really simple. Read from left to right. Pick one option for each thing. And no matter what you do, you will have a coherent English language message that will mean exactly the same thing, but there are 14,000 ways of saying it. Okay? So now you might say, well, how are you going to test this? The trick is, I have no data, so I have to generate data. I'm going to generate data by running an experiment in the same population. But it turns out that in order for me to learn people's preferences over who's a hi person and who's a hello person, I don't have to run 14,000 tests. I only need to run 19. Well, if you're interested in how you do that, take a course on experimental design or come talk to me and we can figure it out. So it turns out that the number of combinations is about, give or take, about 14,000, but the number of elements you have to test is only 19. Now, that's the amazing part. Why? Because I'm going to build a model. I'm not trying to find the message that works. I'm trying to use the combination of messages to generate information, which I will then use to train a model. And then that model will tell me how to score the 14,000, and then I can pick the best one. So that process, this is an idea stolen from all the work that I've done for corporate America, right? So if you think about bandits the way Netflix does it or Uber does it, this is basically the same idea. I'm just applying it to nudges at scale. Okay? And we're going to do this on the population of people who are coming up for renewal. So that's about 15,380 people. And I'm going to do 20 messages plus the control. Here's the results. Okay? So the first experiment is just to collect data. Now what I want you to notice is on the right-hand side at the end, there's the control. That was the message that was already being sent out. If you were doing this just from an A/B testing point of view, you'd quickly see that there are some messages that are worse and some messages that are better. So if you got lucky, you would find one of those ones which was better. If you got unlucky, you would find ones that were worse. And then you would conclude either that the control was good or wasn't good. That's just the luck of the draw, by the way, right? We don't want to do that. So we're not interested in picking up which one's better or worse. Obviously, there are ones that are better. What we want to do is use this data to fit a nice little deep learning model, don't worry about it, right, which now predicts what a person's preferences would be. So essentially what it's going to do is it's going to predict, are you a hi person or a hello person? Are you a loss-averse person? Are you not a loss-averse person? And so it's doing it component by component. That's why there's only 19 things to learn. And then it can then stitch together a message that's tailored right for you. Once you build this model and you estimate everything, you get a table like this. Now, it looks messy, but don't worry about it. Essentially, what I want you to focus on is the first two, hi versus hello. Here's in blue, that's the control message. You can actually read it out. Hello to keep getting CalFresh, fill out your semi-annual report as soon as you can, do it online. So the ones that are fixed, we've ignored. Only the variable ones we've put there. But if you look at the numbers, if you're on average, if you move from hi to hello, the take-up rates go up, or the recertification rates go up. So I should just, if I want one message, it should say hello, not hi. So point-wise, I can do this for every feature, and I get a new message. And the message is, hello, in order for you to keep your CalFresh benefits next month, you must fill out an update by October 11th. Do this now at. So we have now a generative model that is based on actual data and has been optimized for, this is for the average person. But remember, we don't want to do one message. Turns out, there's massive amounts of heterogeneity. Some people are hi people and some people are hello people. Why? I don't know. Do I care? No. I'm not trying to build theory. I'm just trying to exploit the heterogeneity so that the nudge just works for you. Okay? So some people are loss averse, sensitive to loss aversion, and some people are not. We can just exploit this. So the way this is going to work, my model is going to take one given individual. We know the characteristics of that individual that's been used to predict their preferences. I can score all 14,000 messages. So this is for one person, and that's the best message. If a different person will have a different best message, and so on. I will always beat control. At least conceptually, I can't lose, because I'm optimizing over the space of messages. The control is 1 out of the 14,000. I'm just going to pick the best one. Now, I could be wrong because of noise and other reasons, but conceptually, I can't be beat. Right? So on the long run, I will win all the time, every time. That's the big question, though. Did it work? There's a lot of kind of discussions we could have about how this was implemented and so on. I'm just going to give you the big picture kind of idea of what happened. So we implemented this, and you can evaluate in the data, like after we've implemented it, you can just pick up the data and you can evaluate what the effect was. And in this campaign, about 200,000, give or take, a month extra went to poor people. What does that mean for the state of California? In 1 year, $14 million, about, incrementally went to poor people. Okay, so the control nudge, we are talking about the increment over that, so not from like no nudge. This is the incremental effect. So this got picked up by the USDA that runs the food stamps program across the US. They asked me to scale it to the US. That number would be about $4.5 billion. More incrementally that would go to poor people. We can have a discussion about why that didn't actually get implemented. The state of California implemented it, but across the US, wasn't that much take-up, as that's a whole other discussion. Okay? So the key point I'm trying to make is, this is a case or a use case of small models. This is not about large language models. This is a tiny model, like literally very, very small, but that can generate massive impact. You can take language models, and which we are doing now, and take small ones, and then rejig them, or like change the architecture to kind of make it like this. So this was done before language models were as good. But you don't always have, AI isn't just generative AI. AI is kind of this broader field where you can pick and choose ideas and tailor kind of tailor them to your problem. And broadly speaking, you can think of personalizing policies, personalizing interventions. There's nothing special about text. I'm running programs right now in India where we're designing like a heterogeneous video intervention for children to keep them engaged in a program, right? Where you can take the same idea, you can modularize video, and then I can generate thousands of new videos personalized to each child. We're doing this for nudges for the right to education, to get people to take up a lottery that allows poor kids to go to private schools. We're going to try and use this for transfer learning, which is if I learn something, I'd learn a policy that works in one state, can I port it to another state? And then, of course, language models, taking the ideas in this research and say, can we now offshoot the whole generative part of it, of designing the language? Can we just get the language model to play a role there, but still do the optimization and personalized piece on top of that? That's my story, and I'm sticking to it. So we're supposed to play a little something different going on here, so I'm going to give it back.
Thank you so much, Professor Misra. It's now my absolute joy to conclude this session with something a bit different, which is why I got some Arabic coffee with me to make this a bit more engaging for the presenter and for you, the audience. We all know that AI chatbots have rapidly advanced and now help many of us in our daily lives, at home and at work. For the behavioral scientist, chatbots can even use helpful ideas for the potential policy interventions. But is the behavioral scientist still a step ahead of the chatbot? We're going to find out because Professor Sanjog Misra has agreed to go up against the UAE's AI model, Falcon, in a competition to come up with the best solution to 3 different policy proposals. Who will decide who has won? You, the audience. After each round, we will ask you to vote on which solution you prefer, Professor Misra's or the chatbots. Don't worry, voting will be anonymous, so you don't have to be afraid of hurting Professor Misra's feelings. Please join me, Professor Misra. You want to sit down for some Arabic coffee? One second.
I'll pour him some coffee while he's...
Forgot something very important.
If the coffee comes out.
Please, let me have the honor. Thank you. First of all, we will start with our first policy challenge on encouraging public transport uptake in the UAE. The UAE has invested heavily in public transport. As example, we have Dubai Metro, Abu Dhabi public transport, buses, but car dependency remains high, and we want to ask, how can we increase the uptake of public transport, particularly among Emirati citizens who often prefer private vehicles? We will first put the problem to the AI. All right. I think we have our answer from the AI on the screen.
Am I allowed to kind of persuade them to vote for me?
You can feel free to persuade them, but before trying to read from what the AI has answered, we will go with you, Professor Misra.
Sounds good. So the first thing I would do is ask the AI to give me 5 options. It's a joke. So my intervention would be not a nudge, but more an incentive program. The way I would think about this is, look, there's a set of needs that transportation provides, and the fact, as you mentioned, that people have a reason why they prefer private transportation. So giving them kind of a viable way of shifting away. One possibility would be to make it a game, to give them kind of a reason to try something different. And that could be in the form of a sweepstakes or in the form of giving them just a cash replacement and giving them a reason to try something like that might work. It'll take me a little bit more time than the language model to think of exactly what that implementation would be. But I think thinking carefully about what the needs are, what would it take to kind of move them to the other side, or at least try the other side, before going into something like a wholesale, like, pass system. I saw what the AI said. I wouldn't do that. I would try and kind of figure out first, what it takes to get them across. So the first phase would just be giving them incentives to try out something that's not private transportation.
Okay. So the audience has now heard Professor Misra's solution and can read the AI solution on the big screen. So it's time for you, the audience, to vote on which you think is better. Simply scan the QR code, which will be up on the screen, to vote.
The votes are not being tallied by an AI, right?
I don't think so. Who do you think answered better on the topic of public transportation in the UAE? The human, Professor Misra, or the AI? Or you can be a bit more...
Well, look at that.
Already. Okay. The race is still on. Ooh. Professor Misra is still leading. I think
It's getting closer.
it's
Stop
getting
it.
close. Do we have a verdict or not yet? Let's have another 10 seconds. I think the verdict is clear. The majority have voted for Professor Misra.
Thank you.
Let's now see if the outcome is different with another question, which is about reducing water consumption in the UAE, a topic of great importance to countries with a desert climate. How can we encourage households and businesses to reduce water consumption while maintaining quality of life? Let's put the problem to the AI. Sorry. Let's go back. Technology can fail you sometimes.
There you go. So I just win by default.
Oops.
Maybe you just move to the third one. I can tell you what I would, while you're
Yeah.
figuring it out. Here, instead of incentives, I would use an informational treatment. One of the things with water usage, and I'm actually working on a project with a large city in the west of United States, trying to manage water usage and water bills, if you will. But part of the problem is just awareness or information about what your consumption looks like. And so if there's a way of using technology to just let people know what their consumption on a daily basis looks like. So it's one thing to kind of get kind of a report at the end of the month or at the end of the quarter. It's another thing to see what happens when you've got kind of a daily monitor of water usage, breakdown in terms of like, so if again, you're imagining this as a smart system, it tells you like where the water is being used, how much is being used. And I think that would go quite a bit a ways in terms of just getting people to recognize. Look, I mean, water is a necessity, right? People feel like they have a right to use. It's one of those fundamental things. I want to use water. So you don't want to kind of shove them into something. You just want to gently kind of make them aware and make them endogenously pick the right decision.
Yeah.
So empower them to kind of, so information is one good way. If that doesn't work, then I think you can go to incentives and so on.
So believing in the power of human beings having informed decisions.
Right.
I think the AI is still failing
Yeah,
us,
I
so we can jump for the poll right away, and you can start voting.
If the numbers stay at 53-28 now, that's just bias.
1 second. It's still on the public transport. Can we jump to the next? And I don't think the clicker
I
is
think it's
responding.
overloaded.
Can we jump to the Slido? Can we get the QR code? I think we can skip this one for now. Hello. Even the human beings are not responding. Can we move to the third question for now? Okay. I'll just jump to the final question, which is on the topic of female participation in high-tech and AI jobs. So women are underrepresented in AI very clearly, and high-tech jobs as well, across the world. How can governments or employers use behavioral science to increase the number of women working in the sector? Let's first see what the AI solution is. Okay. Hope it's working now. Seems like it. Falcon, do your thing. So we have mentorship and role model programs as an intervention. And we can also go to Professor Misra.
Yeah,
What would be your intervention?
So this is a hard problem, as you're probably aware. So I think there's a supply issue that kind of stems or shows up before you get to this point of jobs in AI. I think if you want to kind of tackle this, you want to kind of go back and say, like, where is the supply, right? Is it the fact that women are being, are qualified, are in the AI space, and then they're not getting the jobs? That I don't think that's what's happening. I think what's happening is one step before that. That there's kind of a, if you look at kind of broadly speaking STEM fields, but computer science in particular, there's kind of a disproportionate number of males to females. And so I think I would go back and I would start thinking about interventions that get girls, high school, or even in college to kind of, change paths, if you will, to move into AI. That could come through grants, through scholarships, that's not behavioral science, if you will, but that's more kind of directly incentives and programs. On the behavioral side, I think, again, so I'll give you an example. In India, where we're trying to get kids from very disadvantaged communities to go to school, and that's not a standard thing that parents in those areas kind of think about. So the informational treatment is to parents to kind of let them know what the consequences, what the long-term consequences of their actions are. There's like a short-term versus long-term trade-off. And I think something like that, getting kind of the decision makers to realize, like, that this is a field that's emerging, that there's lots of potential for their daughters or for their family members to get into this, and kind of encouraging, getting them to encourage kind of the supply to kind of push in the right direction. That's what I would try. I'm not an expert in this field, so just to qualify that.
Let's see what people think. So, please have your scanners ready. Who do you think better answered? The human or the AI? Whoa.
Whoa.
Okay.
It's like high volatility.
If it hits 53 again. No longer a majority. It's still ahead. We'll have another 10 seconds in case AI can beat Professor Misra. All right, 49. And we have a clear winner. Congratulations, Professor Misra.
Thank you. Can I just say something quickly?
Absolutely.
Just as I run the Center for Applied AI at the Chicago Booth School. One of the things to think about this test is this was set up as a substitution test, like as either or, right? I think the biggest kind of advantage of using AI in not just in behavioral science but more generally is to think of them as complements. That we want to use AI to augment the human, not necessarily to replace it. And I can guarantee you that if I was working with the AI to come up with solutions, like I would be more articulate in even my ideas, right? If I'd be able to kind of seed those ideas, get better responses, iterate on that process, refine it, and come to you with a better answer. And I think that one would win, hands down.
Absolutely. I think the human factor is incredibly important in conveying your message, regardless of how much information the AI can come up with. That human-to-human interaction is all what matters as a clear conclusion of today's session. Thank you, Professor Misra, for being such a good sport and playing against the AI. And thank you, ladies and gentlemen. Of course.
What did I win, though?
I mean, we can discuss that later. Thank you, everyone, for joining us.
Yeah,
We will now take a 10-minute break before our final session of the day. Please be back here by 4:35. Thank you. Thank you.